Assalamualaikum and welcome back to Programming Concepts. Today in this video I'm going to show you how to connect a DC power jack for charging the batteries with an LED indicator. So today I struggled a lot to make this. I know it looks messy, but it doesn't matter as long as it's working. So I'm going to use this charger, which is 12 volts and 2 ampere, if you can see that. 12 volts, 2 ampere. And I'm going to power it on. Okay, you see it's powered on. Now I'm gonna connect it here with my Inspectorobot, and you see the indicator is showing that it's connected and it is being charged. So let's see how to make this and what is the circuit for this. Okay, so I have all these required components. This is the 12 volt charger, and this is the DC charging jack, diodes. I'm gonna use only one. LEDs, also required only one, and a multimeter. Okay, so we cannot use this LED directly with the 12 volts because this LED is around 3 volts, and if we give 12 volts to it, it's gonna fry out. So let me give you a demonstration. So I'm going to plug in the charger. As you can see, it's working. Now we measure the voltages, and the outer side of this pin is negative always, and the inner one is the positive. So let's see. So we can see it's 12.21 volts. And now I'm going to power on the LED with 12 volts. So the longer leg of the LED is positive and the shorter one is the negative. So I'm gonna put the positive inside, and then I'm gonna connect the negative to the outer side, and 1, 2, 3. So you saw it just blinked. So now it's not going to work. Now let me use another one with the resistors. So I'm gonna use a new LED. And first let's see if it is working LED or not. So I'm gonna put my multimeter onto the diode check mode and connect the positive longer leg to the positive and the shorter one to the negative, and you can see the LED is working. And now I have these 4 220 resistors, so I'm going to use them. So I'm going to connect one leg to these resistors, and then I'm going to power on the LED with the same charger. Here I'm going to insert the positive one, which is now connected to resistors in series, and then the negative to the outside. And you see now it's lit up and it's not going to fry. So we can see it's still working, no issues. So that's why we are going to use these resistors with the LED, so that the LED doesn't go blown away. Also, we have a diode. So this diode is gonna protect the LED from lighting up through the battery. So as the charger will be connected to the batteries to charge the battery, like this will be connected to the batteries. If we connect the LED without diodes, the LED will be always lit up. Like if we connect the charger, it's going to lit up through the charger, and if we disconnect the charger, the charge from the batteries will flow back and light up this LED. So LED will always be on, but we don't want this. I just want that only LED is lit up when the charger is connected. So I'm gonna connect it so that the charge doesn't flow in the reverse direction. So we can also see that if I put this into the diode check, we can see if we connect the positive to the positive end and the negative to the negative end, there's some readings, 0.606. And if we connect it the other way, like if I rotate it and change the polarity, nothing on the multimeter. You can see it's 0. So the diode works like one-way traffic. So it wouldn't allow the charge from battery to flow back and lit up the LED. So let's get started. First, I'm going to solder the resistors, which are currently not soldered, so they're just twisted. So I'm going to power up the soldering iron and solder these things. Now you can see I have connected the LED through resistors to the charging jack. So now if I plug the charger in, LED is turned on, and if I remove it, it's off. Okay, now we need to focus here on the Inspectorobot. So these are the two wires that are connected to the batteries directly, like they're coming from the battery. So this one is the positive one going through the button. So when we turn this on, the positive is connected to the buck converter, and this one is the negative, which is directly connected to the buck converter. So now we need to connect this in such a way that the positive end connects with the positive here, and the negative here, the middle one, to the negative. So when we plug in the charger, the positive connects here and the negative here, and it goes back to the batteries. As the button is turned off, this wouldn't flow to the buck converter and the main circuit of the Inspectorobot. But for the LED this negative of the LED will be connected to the negative of the batteries through diode. So diode doesn't flow the charge from the batteries to the LED only. So the LED only gets charging from the charger, not from the batteries. So that's the concept. So let's do this. Okay, now I have connected the positive of both LED and the charging jack to the positive of the batteries. Now I'm going to connect this negative with the negative of the jack and the negative of the LED through the diode to the jack. So let's see. Okay, now I have connected the LED to the jack directly. I was mistaken before. We don't need to connect the LED through the diode, but actually the battery to the diode. So the voltage from the battery doesn't flow back to the jack. Okay, now if you see, I connect the battery's negative directly to the negative of the jack. You can see the LED is blinking. But if I connect it through the diode, so you can see nothing happens. So that's how this is working. And when we will be connecting the charger, this one, so let me plug in the charger. Okay, now I plug in the charger here. You can see it is light up. Okay, let's solder the battery's connection here, and then we will verify if the charger is applying the voltages to the batteries, but batteries are not flowing back to the jack. So let's do this. Okay, now the circuit is ready. Let me explain it again, so if there's any confusion, we can clear it out. So this is the button which was before connected to the positive of the batteries. So positive was flowing from here and then through the button to this terminal and going to the buck converter. Now we have connected the jack's positive with the positive directly, like without going through the button. It's just directly connected. So it's now connected to the positive, and then that positive is connected to the positive of the LED through these series resistors, so that the voltage doesn't damage the LED. Then the negative of the LED is connected to the negative of the jack, and the negative of the battery is connected also to the negative of the jack, but through the diode. And then that negative also flows directly to the buck converter. So now if I turn the project on, it's working. You can see the LED on the buck converter, and on the Arduino it's working. And if I turn it off, it's working. And also turning on the project doesn't turn on the charging indicator. Now if we connect the charger, if you can see, yes, the charger here, and now I'm going to connect it here. But before I connect the charger, let's measure the voltage from the batteries. So I'm going to use the multimeter, DC volts, and this is the positive of the batteries, and this is the negative. So you can see it's around 8 voltage, and the battery is low because I have connected 3.7 volts of batteries, 3 batteries. So 3.73 times equals to 11 almost. So it will be 11 if it is fully charged. So now, as we can clearly see, the voltage is around 8. So when we connect the charger to the jack and the charger is correctly connected to the batteries, this voltage will arise. So let's do this. We connect it here. Charging indicator turns on. Now I connect it the same way. Positive here, negative here, and still the voltage is 7.9. But it will increase. So you can see it's increasing, which means the charger is charging. So when it reaches the 11 volts, it means the batteries are full. So let me turn off the charger, connect it again. .95. Let's put some silicone here to fix these things. Okay, now everything is fixed and tightened. Okay, I got the problem. So this is the DC jack, power jack, and when I try to check the connectivity, we can see that this pin, which is on the side of the DC jack, is connected to this one in the middle. Like, let me put it to the connectivity, and you can see this is connected. So I thought these two grounds are always connected, so I was using both of them as the ground, and I thought they are connected, but they are connected in this state. When we put the plug in it, this is detached from this one. So now if I check it, now we can see there's no sound. So this is actually a detector. So this is DC jack connector detector. So when we put the plug in, the negative from here disappears. This one always connected to the ground, but this one no, only when we unplug it. So this was the problem, that when we put the DC jack, it disconnected from the batteries. So I had to connect both of them. So you can see this wire here, like this one here, I connected this side pen with the middle one, and now it's working. So we don't need to connect it if we only use the other pin, the original pin, ground pin. So we should always use this pin, but I had already attached diode with it, and I would have to detach it from here and attach it here, so it was a whole mess. So I decided to just connect them both and do it easily. So that was a hack. So, but it's not recommended to use this pin as ground. It's a detection pin. I hope you got this. Now let me show you the voltages. I have charged the batteries, and now they are working. So now we can see, if you can see the multimeter. Okay, so here 11.1, which is battery full. Okay, now I would put the glue back onto it and finalize it.